Hello everyone, welcome to this session on AWS Interview Questions. Today in this session, we'll be taking you through some of the most asked interview questions among all the AWS profiles which are out there. Now these questions have been collated by talking to top hiring managers who basically hire AWS engineers day in and day out. So let's go ahead and start with the questions. So we will be starting off the questions by first understanding the different domains that we are going to cover. So basically we have divided the questions among 6 domains, right? So following are the domains that we'll be covering. Alright, now before we move on to the agenda guys, if you haven't already, please subscribe to the Intellipaat channel and click on that notification bell icon to never miss out on any updates from us. So now let's move on and talk about the agenda. So we'll start off easy. First of all, we'll talk about some of the generic questions that can be asked to you when you appear for an AWS interview. Then we will move on and talk about questions which are related to security aspect of an architecture. Then we will talk about resilient architectures and what kind of questions can be asked to you with respect to this particular topic. Then we're going to move on and talk about performant architectures, cost of optimized architectures, and finally operational excellent architectures. Now it is very important in a company to basically deal with all these domains because you want cost optimization, you want operational excellence, you want resiliency, you want security. So all these are the questions which companies ask, especially if they are hiring an AWS Solutions Architect. So guys, let's move on and start off with the first domain, which are some generic questions which can be asked to you. All right. So the first question says, what is the difference between an AMI and an instance? So guys, an AMI is nothing but a template of an operating system. It's just like a CD that you have of an operating system which you can install on any machine on the planet, right? Similarly, an AMI is a template or is an installation of an operating system which you can install on any servers which fall into the Amazon infrastructure. All right, you have many types of AMIs. You have Windows AMI, you have Ubuntu AMIs, you have CentOS AMIs, etc. There are a lot of AMIs that are present in AWS Marketplace, and you can install them on any servers which are there in the AWS infrastructure. All right. Coming on to instances, what are instances? So instances are nothing but the hardware machines on which you will install AMI, right? So like I said, AMIs are templates which can be installed on machines. These machines are called instances. And again, instances also have types based on the hardware capacity. For example, a 1 CPU and 1 GB of machine is called T2.micro, right? Similarly, you have T2.large, you have T2.extra large, then you have IO intensive machines, you have storage intensive machines, you have memory intensive machines, and all of these have been classified in different classes, right? Depending on their hardware capability. So this was the difference between an AMI and an instance. Our next question asks us, what is the difference between scalability and elasticity? Alright, so guys, scalability versus elasticity is a very confusing topic, and if you think about it, so scalability is nothing but increasing the machine's resources. For example, if your machine has 8 GB of RAM today, you increase it to 16 GB. Therefore, the number of machines are not increasing. You're basically just increasing the specification of the machine, right? And this is called scalability. When we talk about elasticity, we are basically increasing the number of machines present in an architecture. We are not increasing the specification of any machine. For example, we choose that we require a 3 GB machine with say around 8 GB or 10 GB of storage, right? So any replica which will be made or any auto scaling which will happen, it will only happen to the number of machines. It will nowhere be related to the specification of the machine. The specification of the machine will be fixed. The number of machines will go up and down, and this is called elasticity. On the other hand, scalability is called is basically termed as the change of the specification of the machine. That is, you're not increasing the number of machines, you're basically just increasing the specs of the machine. For example, the RAM, the memory, the hard disk, etc. And this is the basic difference between scalability and elasticity. Moving forward, our next question is, which AWS offering enables customers to find, buy, and immediately start using software solutions in their AWS environment? Now you can think of it as, say you want a deep learning AMI, or you want a Windows Server AMI with specific software is installed on it, right? So some of them are available for free, but some of them can be purchased in the AWS Marketplace. So the answer for this is AWS Marketplace. It's basically a place where you can buy all the AWS systems that you or all the AWS or non-AWS softwares that you require to run on the AWS infrastructure, right? So the answer is AWS Marketplace. Moving on, our next question would fall under the domain of resilience architecture. So all the questions that we'll be discussing henceforth in this domain will all be dealing with the resiliency of an architecture. All right. So a customer wants to capture all client connection information from his load balancer at an interval of 5 minutes. Which of the following options should be chosen for his application? All right. So I'll read out the options for you. The option A says enable AWS CloudTrail for the cloud balancer, for the load balancer. Option B says CloudTrail is enabled globally. Option C says install the Amazon CloudWatch logs agent on the load balancer. And option D says enable CloudWatch metrics on the load balancer. All right. Now, if you think about it, CloudTrail and CloudWatch are both monitoring tools. So it's a bit confusing, but if you have studied it deeply, or if you understand how CloudTrail works and how CloudWatch works, it is actually not that difficult. All right. So the answer for this is A, that is you should enable AWS CloudTrail for the load balancer. Reason being, option B is not correct. CloudTrail is not enabled by default or is not enabled globally to all the services. Option C says install Amazon CloudWatch. So option C and option D, you will not even consider, reason being that you're talking about the log of the client information, right? What all people are connecting to the load balancer, what IP addresses are connecting to the load balancer, etc. CloudWatch deals with the local resources of the instance that you are basically monitoring. For example, if you are monitoring EC2 instance, CloudWatch can monitor the CPU usage or the memory usage of that particular instance. It cannot take into account the connections which are getting connected to your AWS infrastructure, right? On the other hand, CloudTrail deals with all these kind of things wherein client information or any kind of data which can be fetched from a particular transaction, all of that can be recorded in the logs of CloudTrail, and hence for this particular question, the answer is enable AWS CloudTrail for the load balancer. Moving on, our next question is, in what scenarios should we choose classic load balancer and application load balancer? All right. So for this question, I think the best way to answer this question would be to understand what exactly is classic load balancer and what exactly is application load balancer. All right. So a classic load balancer is nothing but, it's an old-fashioned load balancer which does nothing but round-robin based distribution of traffic, which means it distributes traffic equally among the machines which are under it. It cannot recognize which machine requires which kind of workload or it requires which kind of traffic. Whatever data will come to a classic load balancer will be distributed equally among the machines which have been registered to it. On the other hand, application load balancer is a new age load balancer which basically deals with identifying the workload which is coming to it, right? It can identify the workload based on two things. It can either identify it based on the path. For example, you can say that you have a website which deals in image processing and video processing. So you can say it might go to intellipaat.com/images or /videos. So if the path is /images, the application load balancer will directly route the traffic to only the images servers, right? And if the path is /videos, the application load balancer will automatically route the traffic to the video servers. And this is application load balancer. So whenever you are dealing with multivariate traffic, that is traffic which is meant for a specific group of servers, you would use application load balancer. On the other hand, if you have servers which do the exact same thing, right? You just want to distribute the load among them equally, then in that case you would use a classic load balancer. Our next question says, if you have a website which performs two tasks, that is rendering images and rendering videos, both of these pages are hosted on different parts of the website but under the same domain name. Which AWS component will be apt for your use case among the following? Alright, so this I think is an easy question, reason being we just discussed this, right? So the answer for this is application load balancer, reason being the kind of traffic which is coming is specific to its workload, and this can be differentiated easily by an application load balancer. Okay, So we are done with the resilient architecture questions. Now let's move on to the performance architecture domain, where we'll be discussing about how to about architectures which are performance driven, right? So let's take a look at the first question. So the first question says you require the ability to analyze a customer's clickstream data on a website so they can do behavioral analysis. So your customer needs to know what sequence of pages and ads their customers clicked on. This data will be used in real time to modify the page layouts as customers click through the site to increase stickiness and advertise click-through, which option meets the requirement for captioning and analyzing this data. All right. So the options are Amazon SNS, AWS CloudTrail, AWS Kinesis, and AWS SES. So let's first start with the odd one out options, right? So we have Amazon SNS, which deals with notifications. So obviously, because we want we want to track user data, right? So SNS would not be the apt choice for it because sending multiple notifications in a short amount of time would not be apt. Similarly, SES would also not be the apt choice because then we will be getting emails on basically the user behavior, and this would amount to a lot of emails. So hence it's not an appropriate solution, I think. Then we have AWS CloudTrail and AWS Kinesis. Actually, both these servers can do this work, but the keyword over here is real time, right? You want the data to be in real time. So since the data has to be in real time, you will choose AWS Kinesis. CloudTrail cannot pass on logs for real-time analysis. Kinesis is specially built for this particular purpose, and hence for this particular question, the answer will be AWS Kinesis. Moving on, then our next question is, you have a standby RDS instance. Will it be in the same availability zone as your primary RDS instance? Okay. So the options are, it's only true for Amazon Aurora and Oracle RDS. Second option is yes. Third option is only if configured at launch. And the fourth option is no. Alright, so the right answer for this, I want you to think about it like this, that whenever you want a standby RDS instance, it will only be there when your RDS instance stops working. Now, what could be the reasons that your RDS instance could stop working? Probably it could be a machine failure, or it could be a power failure at your at the place where your server has been launched. It can also be probably a natural calamity which would have struck your data center where your server exists. So all of these could be reasons which could lead to disruption in your RDS service, right? Now, if your standby RDS instance is also in the same availability zone as your primary, these conditions cannot be tackled, or these situations cannot be tackled. All right. So it is always logical to have your standby machines in some other place, right? So that even if there is a natural calamity or if there is a power failure, your instance is always up and ready. And because of that, AWS does not give you the option of launching your standby RDS instance in the same availability zone. It always has to be in another availability zones. And that's why the answer is no. Your RDS instance will not be in the same availability zone as your primary instance. All right. So our next question is, you have a web application running on 6 Amazon EC2 instances, consuming about 45% of resources on each instance. You are using autoscaling to make sure that 6 instances are running at all times. The number of requests this application processes is consistent and does not experience spikes. All right. So the application is critical to your business and you want high availability at all times. You want the load to be distributed evenly between all instances, and you also want to use the Amazon AMI for all instances. Which of the following architectural choices should you make? Alright, so this is a very interesting question. So basically, you want to run 6 Amazon EC2 instances, and they should be highly available in nature, and they would be using an AMI, of course, because they are autoscaled. So which among the following would you choose? So you have the options: deploy 6 EC2 instances in one availability zone and ELB, deploy 3 EC2 servers in one region and 3 in another region and use ELB. You should deploy 3 EC2 on one AZ, that is availability zone, and 3 in another availability zone. And you should deploy 2 EC2 instances in 3 regions and use an elastic load balancer. All right. Now, the correct answer for this would be C. The reason being that AMIs are not available across regions. Right. So if you have created an AMI in one region, it will not be automatically available in another region. You will have to do some changes and only then, or do some operations and only then it will be available in the another region. So this is reason number one. So the region options mentioned over here get casted out because of this reason. Second, if you look at the first option, which says deploy 6 EC2 instances on one availability zone, that defeats the purpose of high availability, because like I said, if there is any natural calamity or a power failure at a data center, then all your instances will be down. So it's always advisable to have your servers distributed. But since we have that limitation of using an AMI, and therefore and also the limitation that it is not accessible across regions, we would choose distributing our instances among availability zones. And I'd say we just had the option of two availability zones, right? It could be 3 availability zones and we could deploy two servers in each, and this would also amount to high availability. All right. And of course, because you want to load balance traffic, if you apply an ELB on top of 3 availability zones, it will work like a charm. Regions, across regions, it can become a problem, right? And but in availability zones, it definitely works and it will work perfectly. All right. So the answer for this question is you would be deploying EC2 instances among multiple availability zones in the same region across an ELB. All right. So our next question is, why do we use Elastic Cache and in what cases? All right. So the answer for this is basically related to the nature of the service of Elastic Cache. So Elastic Cache, as the name suggests, is basically a cache which can be accessed faster than your normal application. For example, if you talk about a database instance from which you are gathering information, right? If you're always dealing with the same kind of query, for example, you're always fetching the password for particular users, right? So if you're using an Elastic Cache, that data can be captured or can be cached inside Elastic Cache. And whenever a similar request comes in which is asking for that kind of data, your MySQL instance will not be disturbed. The data will directly be relayed from Elastic Cache, and that is the exact use of Elastic Cache, right? So you use Elastic Cache when you want to increase the performance of your systems, right? Or whenever you have frequent reads of the similar data. So if you have frequent reads of similar data, you'll probably be querying the same kind of data every time, and basically that will increase the load on your database instance. But to avoid that, you can basically introduce an Elastic Cache layer between your database and your front-end application, and that would not only increase the performance but also decrease the load on your database instance, right? So this was all about performant architectures, guys. Our next domain would deal with secure application and their architecture. So let's go ahead and start with the first question of this domain, which talks about a customer wants to track access to their Amazon simple storage service buckets and also use this information for their internal security and access audits. Which of the following will meet the customer requirement? So basically you want to just track access to the S3 buckets. Now if you want to track access, let's see what are the options. So you can enable CloudTrail to audit all Amazon S3 buckets. You can enable server access logging for all required Amazon S3 buckets. Enable the request to page option to track access via AWS billing, or you can enable AWS S3 event notifications for put and post. All right. So I would say the answer is A. And reason being, why is the answer not B? Because server access logging is actually not required when you want to deal with tracking access to the objects present in the S3 bucket. Requester pays option to access via AWS billing. Again, it's not required because there's a very simple feature of CloudTrail which is available to all the buckets across S3. So why not use that? And using notifications for S3 will not be apt. Reason being, there will be a lot of operations that would be happening. So rather than sending notifications for each and every operations, it is better that we log those operations so that whatever information we want out of that log, we can take, and rest we can ignore, right? So the answer for this is Amazon using AWS CloudTrail. Okay. Our next question is, imagine if you have to give access of AWS to a data scientist in your company. The data scientist basically requires access to S3 and Amazon EMR. How would you solve this problem from the given set of options? Okay, so you basically want to give a particular services access to an employee, and we want to know how would you do that. Okay, so the options are we should give him credentials for root. Second option being create a user in IAM with a managed policy of EMR and S3 together. Create a user in IAM with managed policies of EMR and S3 separately. Give him credentials for admin account and enable MFA for additional security. Okay, so a rule of thumb, guys, never give root credentials to anyone in your company. Even yourself, you should never use root credentials. Always create a user for yourself and access AWS through that user. All right. This was point number one. Second, whenever you want to give permissions to services or permissions of services of particular services to people, you should always create or use policies that pre-exist in AWS, right? So when I say that, I basically mean never merge two policies. Okay, so for example, if you're using EMR and S3 together, that basically means that you create a policy that gives you the required access in one document. That is, in one document you mention the access for EMR, and in the same document you mention the access for S3 as well. Well, this is not suggested. Reason being, you have policies created by AWS, which are basically created and tested by AWS. So there is no chance of any leak in terms of security aspect. Second thing is, see, needs change, right? So if tomorrow your user says he doesn't want access for EMR anymore, he probably wants access for EC2. Right? So in that case, what will you do? If you had the policy in the same document, you would have to edit that document, correct? But if you created documents separately for each and every service, all you have to do is remove the document for EMR and add the document for the other service that he requires, probably EC2. You just add the document for EC2 and your S3 document will not be touched, right? So this is more easier to manage than to, writing everything in one document and editing the code later to give permissions of specific services that he requires now, right? So that is something that is not much manageable. So the answer for this is create a user in IAM with a managed policy of EMR and S3 separately. All right. Let's move on to the next question. So how would a system administrator add an additional layer of login security to a user's AWS management console? So this is a simple question. The answer for this is enable multi-factor authentication. So multi-factor authentication basically deals with rotating keys, that the keys are always rotating. So every 30 seconds, a new key is generated, and this key is required while you're logging in. So once you've entered your email and password, it will not straight away log you in. It will again give you a confirmation page for a code that you have to enter, which will be valid for those 30 seconds. Now this can be done using apps. So you have an app called, if you have an app from Google, you have apps from other third-party vendors as well, right? So these apps are basically compliant with your AWS, right? And you can use them to have access to the keys which are changed at every 30 seconds, all right? So it is better. If you want to enable multi-factor authentication, it is the best way of adding a security layer over the traditional username and password information that you enter. All right. So our next domain deals with cost optimized architectures. So let's discuss these questions as well. So our first question is, why is AWS more economical than traditional data centers for applications with varying compute workloads? All right, so let's read out the options. So we have Amazon Elastic Compute costs are billed on a monthly basis. Okay. Amazon EC2 costs are billed on an hourly basis, which is true. Amazon EC2 instances can be launched on demand when needed, true. Customers can permanently run enough instances to handle peak workloads. All right. So I'll say, because this question is talking about the economical value of AWS, option B and option C are correct. Reason being, you're charged according to the hour and at the same time you can have them on demand. If you don't need them after 2 hours, just pay for 2 hours, and then you don't have to worry about where that server went, right? So this is very economical as compared to the fact that when you buy servers and their need finishes, say after 1 or 2 years, when their hardware gets outdated, so it becomes a bad investment on your part, right? And that is the reason AWS is very much economical in terms of reason being that it charges you according to the hour, and also gives you the opportunity of using servers on the basis of on-demand pricing. All right, so this would be the answer. So option B and option C would be the right answer for this particular question. Moving further, our question says you're launching an instance under the free tier usage from EMI having a snapshot size of 50 GB. How will you launch the instance under free usage tier? So the answer for this question is pretty simple. It is not possible, right? You have a limit on how much of snapshot size you can use that would fall under the free tier. 50 GB is not the size, is basically a size which will not fall under the Amazon free tier rules, and hence this is not possible. All right. Our next question says your company runs a multi-tier web application. The web application does video processing. There are two types of users which access this service: premium users and free edition users. The SLA for the premium users for the video processing is fixed, while for the free users it is indefinite, that is a maximum time limit of 48 hours. How would you propose the architecture for this application, keeping in mind cost efficiency? Alright, so to rephrase this question, basically you have an application which has two kinds of traffic. One is free traffic and one is premium traffic. The premium traffic has an SLA that the tasks should be completed in say 1 hour or 2 hours. The free traffic, they do not guarantee it when it will finish, and it has a maximum SLA of 48 hours. So if you were to optimize the architecture for this at the back end, how would you design the architecture that you get the maximum cost efficiency possible using this architecture? All right. So the way we can deal with it is there is a thing called spot instances in AWS, which basically deals with bidding. So you bid for AWS servers in the lowest price possible, and as long as the server prices are in the range that you specify, you have that instance for yourself. So all the free users who are coming to this website can be allotted to spot instances because there is no SLA. So even if the prices go high and the systems are not available, it does not matter, right? You can wait for the applications for processing if you're dealing with free users. But for premium users, since there is an SLA, you have to meet a particular deadline. I would say you use on-demand instances. They are a little expensive, but I think because premium users are paying for their membership, that should cover that part. And spot instances would be the cheapest option for people who are freeloaders or people who are coming free on your website, because they do not have any urgency of their work and hence can wait if required if the prices are too high for you. Alright, so our next domain will talk about operationally excellent architectures. So let's see what all questions are covered in this particular domain. Alright, so imagine that you have an AWS application which is monolithic in nature. So monolithic applications are basically which do not which have the whole code base in one single computer, right? So if that is the kind of application you're dealing with, it's called a monolithic application. Now this application requires 24/7 availability and can only be down for a maximum of 15 minutes. If had your application been not monolithic, I would say that there would be no downtime. But since it's a monolithic application, the question has mentioned, there is an expected downtime of say 15 minutes. How will you ensure that the database hosted on your EBS volume is backed up? Now, since it's a monolithic application, even the database resides on the same server as that of the application. So the question is, how will you ensure that a database is backed up in case there is an outage? So for this answer, I'll say the answer is pretty easy. You can schedule EBS snapshots for your EC2 instance at particular intervals of time, and these snapshots would basically act as a backup to your database instances which have been deployed on EC2. So hence the answer is EBS instance snapshots. All right. Our next question is, which component of AWS global infrastructure does AWS CloudFront use to ensure low latency delivery? Now, AWS CloudFront is basically a content delivery network, which basically means if you are in the US and the application that you're accessing has servers in India, it will probably cache the application in a US server so that you can access that application faster than to send traffic packets over to India and then receiving them back. All right. So this is how CloudFront works. It basically caches the application to your nearest server, and so that you get the the minimum latency possible, and it is possible using AWS Edge locations. Okay, so edge locations are basically the servers that are located to near your place or near a particular availability zone, which basically cache the applications which are available in different regions or are at far places. Okay guys, now this brings us to the end of our AWS interview questions. So if you like the video, please hit the like button, and if you have any more questions, you can put it down in the comment section and my team will be happy to help you out. Right? For more such videos, please subscribe to the Intellipaat channel and click on that bell icon, and we'll be coming up with more useful videos for you with respect to this technology. Thank you for attending today's session. Have a great day.